We are going to review the basics of inequalities. This is a review for you. An inequality means that we have a mathematical statement where there are many numbers that can be solutions. There's just not one. Not just one number, but many numbers. That's an inequality. So if we look at what we have here, 2x minus 3, this is an equation. What gave it away is this little symbol right here. See that equal sign? That is an equation. And it's an equation because if I solve it, one number comes up that will make it true. If I do all the solving techniques, I get x equals 12. If I put 12 in for x, I get a true statement. This is an equation. Now this is an inequality. What's different? Well, there's no equal sign. There's a greater than or less than, greater than or equal to, or less than or equal to. And this tells me that there's more than one answer. Why? Well, if I were to solve this, just like I solve a normal equation, I would end up with x is less than 12. And what that means that every number less than 12 will give a true statement. For instance, if I put 10 in there, it will give me a true statement. 5, it will give me a true statement. Negative 35, it will give me a true statement. It has more than one solution, and in this case, it has infinite solutions. There's no way I could list all the solutions to this inequality. More than one number will make the statement true. All right. So we decided this was an equation, and we knew it because we saw the equal sign. And we decided this was an inequality because we noticed the symbol for greater than. Now, do we solve them the same way? Nearly, almost exactly do we solve them the same way. But we do have a couple of things that are a little bit different. So let's start and let's just experiment. Here's our inequality, not an equation, an inequality. How would we start it if it was just a regular little equation? We would distribute. So let's distribute our negative 4. And we now have negative 2x minus 2 greater than negative 4x minus 10. Now we need to get all the x's on one side, all the numbers on the other. You may do it differently than I do, and not everybody does it exactly the same. But I've decided I'm going to take that negative 2x and I'm going to put it over on the other side. If I put the negative 2x on the other side, then it's a positive 2x. It was a negative 2x. I put it over here. Now it's a positive 2x. And when I got it over there, I noticed I need to combine some like terms, don't I? There's a negative 4x and a 2x, and that's going to give me negative 2x. Well, I still don't have all my x's on one side, all my numbers on the other. I think the next thing I need to move is 10. If I take that negative 10 and shove it to the other side, it'll be a positive 10. It was a negative 10, now it's a positive 10. And I noticed I need to add some stuff together. And so now I have 8 greater than negative 2x. I have all my x's on one side, I have all my numbers, constants on the other. Now, up until now, we haven't done anything different at all, have we? This is the same old solving that we've always done. Now it gets just a little bit harder because there's a very important rule that we need to remember. Whenever we divide or multiply by a negative number, not a positive number, a negative number, you need to remember something. The inequality symbol has to reverse. Because what you did is when you divided by a negative, you just jumped to the other side of the inequality sign. You just picked up and went to another place. So when we divide by negative 2, we have to reverse the symbol. So if we had greater than, Now we're going to have less than. So let's look at what we do. We know we need to divide. Dividing is always last. Dividing is always last. Dividing is always last. So we need to divide by -2. And the reason we need to divide by -2 is because we need to get rid of these -2's so that there's only one x left. And what did we have to remember about dividing by a negative number? Well, instead of it being greater than, it now has to be less than. So let's finish up what we've got. 8 divided by -2 is -4, and the -2's cancel, and we have just an 8. So we have our answer. Now, what are some of the possible, what is -4 less than? Well, -4 is less than 1, and less than 2, and less than 10, and less than 20. Do you want to try to list all those? Well, it's impossible. You can't list all the answers. You have to graph. Graphing is the only way you answer an inequality because that's the only way you can show all of the answers. So let's remember a little bit. If we have less than or if we have greater than, that's an open circle. Now you may have memorized that, but now it's time for you to understand it. It's an open circle because there's no little line for equal to. And if there's no little line for equal to, it means that whatever number is inside this circle, it's not an answer. If this circle is around 5, then 5 is not an answer. If this circle is around -2, -2 is not an answer. Understand what the circle means. The open circle means you can't use this one. It's not a solution. But if you do have the little line, that means less than or equal to, greater than or equal to, and that means that whatever this circle is over, if this circle is over 5, then that is an answer. If this circle is over 2, then 2 is an answer. This value is part of the solution set. So understand what the circles mean. All right, so we have -4 is less than or equal to x. Well, the first thing we need to think of is what does this really mean in English? -4 is less than all the values of x that I'm looking for. If it is less than, then that is an open circle. If it is less than, that's an open circle. And we put that open circle on -4. Now, what does that mean again? That means -4 cannot be an answer. It is not a solution. All right, so we decided -4 is not a solution, but we need all the numbers that are larger than -4. So let's think of a few. If I put 5 right there, is -4 less than 5? Yes. So we need to draw our line toward 5 because we know 5 works. If we tried another one, what if we said -4 is less than 10? Is that a true statement? So our line goes through 10. All right, so let's start one from the beginning, make it a little harder. What's the first thing we do? Distribute. So now we have -15x plus 35. Did you notice that? A negative times a negative is a positive. This right here is the worst part of Algebra 2. It's the negatives. If you don't understand negatives, you will struggle all of the time. All right, so we notice this. Now it's time to get all of the x's on one side, all of the numbers on the other. Well, it seems to me all we have to do is move 35. If we move 35 to the other side, it'll be -35. It was +35. Now it's -35. And as soon as we move it over there, we realize we need to combine some like terms. And so we have negative 15x is greater than or equal to negative 20. Last step is divide. Last step is divide. Last step is divide. We're going to divide by negative 15 because we need that negative 15 to go away. We need just x left behind. So if we divide by negative 15, we have just x. And if we divide negative 20 by negative 15, we have just 8. Now, what is the big important thing that we need to remember? If we divide by a negative number, the symbol has to switch. Now it's less than or equal to. And since it's equal to, we know our circle has to be colored in, doesn't it? Because 8 can be an answer. 8 can be an answer. So we're going to send our little ball over there to 8. That's where it's supposed to be. And we are looking for numbers smaller than 8. Well, what's a number smaller than 8? 7. So our line, what about 1? Is 1 less than 8? Now I know you may have thought you knew what direction, but these are going to get hard. And you need to think about using a number and making sure you're right. So we knew it had to go that way. So you have some practice problems you need to work on. And I'm going to end with the all-time best science fiction series ever, Firefly, and the famous comment, I aim to misbehave.